Music is often used as a compliance tool in the planning system. So we have the planning and regulatory framework and requirements that are set out, and we then have now in place some music modelling guidelines for South Australia. And then looking beyond that at the design level, we also have the Water Sensitive Urban Design Technical Manual for Adelaide. Obviously that's getting a little bit dated now, but it still has some really useful material in it, so we're still referring back to those as the main design reference in South Australia. Using it to make a decision, are people complying with the guidelines that we've set out? So the WSID policy for South Australia sets out guidelines for stormwater runoff quality. You've got to meet 80% for suspended solids, 60% for phosphorus, 45% for nitrogen, and it's also 90% for gross pollutants. So the question we're usually asking ourselves is this development application complying with these requirements? And that's what we're using music to assess fundamentally. There's a few other requirements here. There's some things around water conservation, flood management and so forth. Generally, we're not relying primarily on music to make an assessment on these things, but that doesn't mean that it might not come into some of those considerations, particularly around water conservation. So most likely you'll be using it for development planning assessments, and this is probably the time you're most likely to be using the music auditor, where a consultant will be submitting a music model to a council. Council will be assessing that model, checking that it complies with all the requirements and checking that the music model is as they expect. The other possible scenarios are where you're doing stormwater management plans more broadly, or catchment management plans, where council are also working on water sensitive urban design retrofits within their area of responsibility. So you can still use the auditor in these contexts as well to identify if there's anything out of place. Just a note on the guidelines that have been brought out for South Australia. The intention of these guidelines is to provide some broad guidance on typical usage to help support consistency, so that we're all singing from the same song sheet, we're all using the same assumptions and parameters, that when council get 5 music models, hopefully they're getting 5 models with fairly similar parameters in them. But at the same time, the intention is not to stifle innovation and to prevent people from improving on that. While it sets out some basic principles, if people want to make the effort because they're working on a particularly important project in a local area, the intention is not to stop people from really localizing their climate assumptions or their soils assumptions, so that it's really specific for that project in that location that they're in. Wherever someone is willing to make the effort to do that, I think that should be encouraged. So I'd take that as a note for any authorities assessing models. If people are doing that extra effort, then take that on board and where possible support it. Essentially, we want to get 2 things out of assessment. Firstly, we want to end up with WSID assets that actually work. They meet the planning objectives and requirements, they're functioning well, and they're effectively protecting the environment. And ideally, they're sustainable and durable. They're actually going to last and stick around. So we need the models to be reasonably accurate representations of these systems, but there's more than just the modelling. There's a whole suite of design guidance and maintenance and other things that also need to happen for all of that to actually work. The second thing about the assessment process, though, is that it should be fair and objective. If a council is sitting down and assessing 5 different development applications, we'd like to think that each of them will be judged on the same criteria and assessed in the same way, so that everyone's getting equal treatment. Some of the time as consultant, you may like or dislike what council are telling you, but what you want to know is that everyone is getting the same advice, that we've got clear expectations, there's clear requirements, and we all know what we need to do. At the same time, I feel like it's important to flag that we need to recognise modelling as not by any means an exact science, and we need to balance what might be a hard and fast rule in the guidelines or in a specific council requirement with some competent judgment and some recognition that sometimes there's grey areas, sometimes there is a need for variation, and sometimes there's opportunities for innovation. And that's not to say that we shouldn't be using that as justification to say, oh, we didn't quite meet the 80-40, 80-60-45, can we get away with something a bit less? That's not really what we should be trying to justify. But where there's other guidelines that set out requirements, you might be saying, well, look, it says that the depth of this system can't be more than this, or it has to be at this level. We're slightly over it, but we're compensating for it in another way. So that would probably be a reasonable approach. Or you may have specific design limitations. You might have an invert drain that is only 300 mil below the surface and your depth requirement is 400 mil. Physically, it's not possible for you to meet that because you're limited by the downstream drainage. And in those situations, you might make an argument for making some adjustments to what you're actually modelling and designing. So imagine you're working for a council, someone sent you a music model, looks a little bit like this. Your planner's asked, can you have a look? Please tell us if it's okay. The consultant has said, meets all the objectives, meets the 80, 60, 45, ticks the boxes. Where do you begin in assessing this? You've got 20, 30, 40 nodes in the model. They've got all sorts of parameters in them. You've got treatment nodes with various things going on. You've got no idea whether anything in this model is correct or not. Where do we begin? On the one hand, this is intended for council to assess a consultant model, but I'd strongly encourage you to self-assess your model. Then you know what council are going to pick up and flag, and you can head that off. You can say, okay, they're going to identify these things. Let's just fix that. Not a problem. Council won't bother us with those. These ones are something that we want to stick with, so let's justify it and put in our report and explain why we're doing it. And that gives you a shot that when you submit this to council, council look at it and they're happy with everything that's there. They tick it off and it passes through, and they don't have to come back to you with questions. That's what you want in an ideal world. If they're coming back to you asking for changes, then there's an iterative cycle. You've got to do more work, costs the client more, council spend more time reviewing the second round, wastes everybody's time. So if you can self-assess, much easier for everyone. A few questions that I would ask myself when I'm looking at a model. Questions to ask are, is it realistic? Is it reasonable? Is the model actually representing what the design is? That's the function and purpose of a model at the end of the day. We've always got to ask ourselves, are we actually representing what's in the ground? It's one thing to follow the guidelines, but if it's not representing what we're designing and building, then there's not much point. Second one is, does it comply with the guidelines? And does it fit in with sort of general good design and common sense? And that's where the music auditor comes in to do those checks of the various input parameters against the guidelines. The other things that I would be looking for is, does it match up with the plans? Is always a good idea. You kind of expect that, but sometimes people make mistakes. So it's a good idea just to check that the model layout makes sense with the design, everything's where you expect it to be. And also that things like catchment areas match what's on the plan, what's in the model. The size of treatment systems, the bioretention is 10 square meters. Is it 10 square meters on the plan? It's really simple stuff, but it's worth checking those things just to make sure everything's as you expect. These are the kind of checks that anyone, a planner or an architect sitting in council, can actually do themselves. They can sit down and look at the plans. They can look at a printout of the model and satisfy themselves that these things look okay. The last thing to look at is it justified? So you might have a music auditor report, identifies a bunch of things that have been flagged. Have they justified those and provided a good reason for why they're deviating from the guidelines or why they're deviating from what's been picked up in the auditor? Always check that the catchments and the drainage layouts make sense, that the whole catchment's in the model. One really common thing that gets missed is that a treatment asset in music is influenced by everything draining into it and its whole catchment. So if your development has another development draining into it upstream, you should ideally be including that in your model so that you can then see what the effect of that is on the treatment performance of your assets. You may then make an adjustment and say, well, we only need to meet load reductions for our development. So we'll do some spreadsheet calculations to calculate whether we're meeting the load reductions just for our development, but you should be taking account of those upstream areas coming into your model, because sometimes it makes things better, sometimes it makes things worse. Another simple one to check is the order of the treatments, as you'd expect. Have we got primary treatments like gross pollutant traps and sediment ponds upstream? And have we then got bioretention and wetland downstream? Have we got swales generally upstream? Have we got something like an infiltration system? You expect that to be downstream of a sediment treatment. So anything deviating from that, you might pay some attention to. Here's an example layout. This is a music model for a townhouse development. So some really simple checks for the planner. We've got townhouse roofs clearly identified here. Where are they draining? They're going to the rainwater tanks. That's what we expect to see. If we start looking at this and the first thing we see is there's a driveway going to a tank, that's going to be a red flag, because we'd expect all of the ground surface areas like driveways and gardens will be going out to the outlet or going through some other sort of ground level treatment, not through a rainwater tank. I've picked up stuff where we've had loading docks going to a rainwater tank, and I was like, well, sure, you can do that, but that's going to be a lot of work to prove that that water is safe for someone to then be using it as treated rainwater. You're going to have to put UV and filter systems and all sorts on it. Honestly, for a loading dock, it's probably not worth the money. So it's always worth checking these things make sense. The other obvious one there is, are the treatments in order? This is another example. You've got GPT, bioretention, all good. Then you've got seed basin. Hang on, why is that downstream of the bioretention? Okay, maybe that's on the wetland and there's a reason for that. If there was other catchments coming in, maybe that would make sense. I'd be very concerned if I got a model coming in that looks like this. Bioretention upstream of a wetland is okay. It will mean that it has some interesting effects on treatment performance because a bioretention can do a better job than a wetland can. But if these were the other way round, what happens is that the wetland tends to release water slowly over a long period of time. So in theory, it's a good idea to put a bioretention downstream of a wetland because then you can treat the water to a better standard. But in practice, what it means is the bioretention gets completely saturated with water and stays wet for a long period. And then the plants in the bioretention die. So it's not really a good idea to put a bioretention downstream of a wetland. So we're looking that we don't have anything like that in our model.